Welcome to the TechHub.training Excel Mortgage Modeling Challenge solution. In this video, I'll walk you through how to build one model that will solve the answers to this challenge. It's important to note that there are many different ways and many different formulas that you can create that will help you answer these questions. In the challenge description, it reminds us that green cells are going to be manual inputs, blue cells should be dynamic formulas. The combination will help us to create a model that will help us answer the questions found on this sheet. So let's start at the beginning. Question number 1 asks us to find what the mortgage payment will be if we purchased a home on December 2nd, 2022. So in the date, let's go ahead and enter that information. Next, we need to find what the 30-year rate is on that date from the data table that's found over here. There's lots of formulas you can use, like I said, but I'm going to use an XLOOKUP formula. First, I need to know what the lookup value is, which is this date here. The lookup array, which is going to be column A. We want to look up in this date column. The return array, we want to return a value from the 30-year rate. And I'm going to specify the match mode to be an exact match or next smaller item, which is -1. Essentially, this will just look for the value that we specified, and if it doesn't see it exactly, it'll look for the date previous, but it will be as close as it can. And we will close this formula. Now look, we can see that our percentage does not look right. In the data tab, it's specified as a 6.49, but here it's 649%. Based off of the cell formatting, we can go ahead and adjust that by dividing by 100, and we get it properly here. I'm going to do the same formula for our 15-year rate as well. Again, we want to look up this date in the date column. This time we want to return a value from the 15-year rate column. And again, I'm going to specify the match mode to be a -1, divided by 100, and we get our answer here. And now we can go ahead and we can verify this. We're looking for December 2nd, 2022. Well, December 2nd, 2022 is not here, but it found the next earliest date, and we can see it's 6.49 and 5.76, which is here. This next one asks us to select a rate. It's a drop-down list. We could pick a 30 or 15-year rate, depending on the question and which mortgage rate we need to select an answer for. For our annual rate, you can use an if statement. I'm just going to use another XLOOKUP since we have been using that thus far. We want to look up a 30-year rate from these two options, and we want to return the rate associated. And we don't need to specify much more past that. So we see that we get the proper rate, and if we change it to 15-year, it pulls the proper information for us. We can make this annual rate a monthly rate simply dividing by 12 months. The loan period we know is 30 years or 15 years, but we need to get this in months for our payment formula we will create later. So I am going to use a left formula, pick the first two characters from this column, and multiply it by 12 months. So you can see this is 30 times 12 gets us 360, or 15 times 12 gets us the 180. Our assumptions for the first batch of questions is that the home price is $400,000 and the down payment is $10,000. The mortgage amount is just going to be calculated as the difference between the two. Our mortgage payment, we can use the payment formula. For our rate, we want to use our monthly rate that we calculated. Our number of periods is the loan period in months. Present value is the current balance, or the starting balance, I should say, of the mortgage. And our future value is going to be 0 because we're going to pay this off in full. And you can see that based off of the formatting of the equation, it makes this a negative number. I'm just going to flip this to a positive number just for presentation's sake. Let's move over to the amortization table now. We are going to set our payment equal to this value which we just calculated here, and I am going to lock this formula to always reference this cell. This will make it easier for completing all 360 months of the amortization table. The interest portion of this payment is the prior period's loan balance multiplied by our monthly interest rate. And I am going to just lock this interest rate cell in this formula. The principal amount of the payment is just the difference between payment and interest. The extra payment category is a manual input, and the questions may or may not ask us to include that later on. So we will skip that for now. Our balance is just going to be equal to the prior period's balance subtracted from, and we subtract out the principal paid this period as well as any extra payments that we may make on the mortgage. Once we have these formulas entered, we can select them all and drop it down. Now you can see that over a 30-year term, or 360 months, the balance on the mortgage will eventually hit 0. The same is true for a 15-year mortgage in month 180, as you can see here. Let's look at the last two inputs over on our variables table. You see that in question number 7, it asks us a question about having our mortgage payment only be a certain percentage of our annual income. Question 7 specifies we want our mortgage payment to be 30% of our annual income. It asks how much annual income we will need for this payment to be possible. So I'm going to take our monthly payment and annualize it by multiplying it by 12 months, and then I'm going to divide by our 30% to get the annual income that we would need to have for our mortgage payment to be only 30% of our take home. And that gets us $129,627. Now that your model is set up, you can go through and change some of these variables in the green cells, and the table will adjust and it will give you the information that you need to answer the questions provided here. Thank you for following along on this solution. Like I said before, there's many different ways that you could solve this challenge. You could nest your formulas if you don't want to split it out into this finer level of detail. But I'm excited to see the challenges and the solutions that you come up with.